All right. Hello, everybody. Welcome to, hello. Thank you for your response. Welcome to the 24th annual Round Robin Colloquium. I actually have no idea how many years it's been, but this is a storied tradition here at APS. So, how this is going to work, we currently have, I think, like 35 slides or something. So everyone gets a minute before you are air horned off of the stage. So yeah, I will download an air horn and I will play it at you. So I'll give you a little wiggle room because we don't have like a full 50 people that are talking. So you'll get a little wiggle room, but not too much. If you're a talker, don't pretend I didn't say that. Okay, so everyone's gonna come up. If you know roughly where you are in the queue, that would be great. I will when I will like say the next person that's on bat, and no, sorry, on deck. I don't know baseball very well. And you will come down here so that you are ready to present your slide when it is your time. Okay, and yeah, I say who you are, say what you're interested in. Maybe you can say what you like doing outside of work if you want to. All these things are cool. Okay, great. One more announcement before we start is if you have an administrative issue, which is almost any issue related to Colloquium, please email Robin and not me. Thank you. Please email Robin, not me. Yeah, if you have something related to the listserv, if you have something related to the website, these are not, if related to food, these are not my issues. Please email Robin. Okay, thank you. Okay, who's next? Kevin, you're next. Get down here. You're on deck. Okay, I'm Erica Nelson. This is my fourth year as a professor here. I work on galaxy formation and evolution, in particular with James Webb. James Webb is my baby. I love it. Maybe I'll turn down, I don't know how to do that. Oh yeah, perfect. Outside of work, I like to climb and ski. Kevin.
Real quick, we are planning to record this and put it on YouTube. Okay. Keep the swearing to a minimum. Gotcha. I'm Kevin France. I'm an associate professor here in APS. I've been a professor in APS since 2015, but I've been here at CU since 2007. This is my slide that I show every year, but what I'm really working on this year is now the thing in the center. That's the Habitable World, a picture of the Habitable Worlds Observatory. This is NASA's next flagship mission that will find habitable planets around other stars and do transformative astrophysics in all areas. So NASA is just kicking off this effort now, and we're excited about having this happen before I retire.
Yeah, I'm Yuta. Okay, I'm Yuta. My name is Yuta Notsu, and I'm a last postdoc, and I'm working on stellar flares and recently also stellar CME candidates. And my methods as observations, especially I think I'm heavy user of Apache Point Observatory, and I'm also recently also work forward to effects on planets. And also I'm living in Boulder, so I like skiing and hikes like these pictures. Okay, who's next?
Paul. Okay, well. Okay. I don't know why you.
Yeah, I am obviously not Paul Hain, but he has deputized me to give his slide. Paul studies the surface and atmospheres of planetary bodies with a focus on how ices and atmospheres interact to produce the diverse climates of our solar system. Here, you can see an array of atmospheric densities resulting from the range of temperatures and compositions on Titan, Mars, and the dwarf planet series. Thank you.
Thanks.
Okay, hi, I'm Dave Malaspina. I'm assistant professor here since 2020. Up here is an array of stuff that I do, but basically it's related to electric and magnetic field instruments, measuring plasma waves and their exchange with particles within the heliosphere. Thanks.
All right. Hi, I'm Steve Cranmer. I'm an associate professor here in APS since 2015, also serving as the associate chair for graduate studies right now. Up here is just a collage of models and observations of the solar corona that I put together. A lot of my research, which is in collaboration with some awesome students and continuing with some awesome former students who are still here in Boulder, involves trying to solve the coronal heating problem, trying to understand the acceleration of the solar wind along these magnetic field lines that are escaping the sun, and then extending those theories to other stars. Some other research includes the winds of other luminous things like AGNs, and some recent forays into infinite number theory.
Yes, this one. Hi, my name's Adina. I'm a new Sagan postdoc over at LASP, but I spend about 1/5 of my time here. My research focuses primarily on understanding really young planets right after they formed and trying to understand their atmospheres and how their really active young stars interact with those atmospheres, stuff like that. I'm an observer, so I have used JWST. I use a lot of test data. During my graduate studies, I was also fortunate to spend a lot of time down at Magellan, which is really beautiful, and also using HST. Outside of work, I spend a lot of time with my 2 cats, Rex and Slinky, who like to go outside, which is really fun here in Boulder. And I also, like Zach, like to crochet and knit. So very happy to be here.
Amy, you're next. Hi, everyone. I'm Joe Simon. I'm an NSF postdoctoral fellow here. I work with Dr. Julie Comerford and her research group. I think I'm the only gravitational wave astrophysicist in the department, so I use pulsar timing arrays to study supermassive black hole binaries and try to figure out what they can tell us about galaxies and all of that cool stuff. Yeah, that's me.
Hi, I'm Amy. I'm a 5th-year grad student in Julie's group with Joe. I'm broadly interested in galaxy mergers and how that affects galaxy evolution, how to identify them better with interpretable machine learning, and what effects that process has on AGN feedback, accretion, star formation, everything like that. And then outside of work, I really like baseball. I like cheering on the Red Sox. I like skiing here in Colorado, and I also work at an equine therapy barn.
Hi, my name is Emily Griffith. I am a postdoc in CASA, and I study the origin of the elements using stellar nucleosynthesis and spectroscopic data from the Sloan Digital Sky Survey. CU Boulder is part of STSS-5, which it has a Milky Way mapper program, a black hole mapper program, and a local volume mapper program. If anybody is interested in getting involved with the survey or accessing the data, I'm happy to help you get involved. It's a really amazing collaboration, and I have a plot of like their expansion across the Milky Way, which is really incredible. When not doing science, I hang out with my puppy, Root, and my parrot, Kyrie.
Hello, I am Professor Andrew Hamilton. I've been here since 1986, and this is what happens when you hang around for a very long time. Last year, I told you in this spot about a new grand unified theory that unites 4-dimensional space-time with a grand unified group spin 10, non-trivially in a 11+1 space-time dimensions, spin 11.1. This year, I've been developing a spin 11.1 string theory. The string theory is a 12-dimensional theory in which a 10-dimensional internal Calabi-Yau manifold, that's the thing on the right-hand side, flexes non-trivially inside 4 large space-time dimensions. Under the hood, it is a 26-dimensional bosonic string theory which compactifies to 12 dimensions on the 14-dimensional maximum torus of SU8 cross SU8. The weak and color forces are carried by open strings whose ends attach to the aforesaid 10-dimensional fermionic Calabi-Yau manifold. It is not supersymmetric, so it does not predict superpartners that the Large Hadron Collider has not seen. A Calabi-Yau manifold with 10 dimensions offers much more scope for the universe to make its DNA than just 6 dimensions. The multiverse just got a whole lot bigger. If you have no idea what I've just talked about, think exo-universes.
How do we advance this? Okay. Is this the one? So I'm John Bally. I'm retired from teaching, but I still do my research on star formation and feedback. And I have a rule. Show me an accreting, spinning, and magnetized system, and I will show you a jet. I don't care if it's a neutron star, black hole, or young star, or planet. Here are some examples. That should be animated. It's not in this case. One development recently is that amongst massive stars, the outflows can be explosive and very violent, triggered by probably protostellar mergers. Orion's our best case. We have another half dozen cases now in the galaxy. I also am involved, I'm a co-PI on something called ACES, the Atacama or ALMA Central Molecular Zone Exploration Survey, which is mapping about 24 molecular lines over a square degree of arcsecond resolution. The question in my mind there, what dominates feedback and the ecology of the interstellar medium? Is it the black hole, or is it massive stars produced by star formation? Anyway, I also ski.
Hi, hello. Yeah. Hi, I'm Dave Wilson. I'm a research scientist at LASP, and I do UV observations of any kind of star, basically. My bread and butter is making these. This is a panchromatic spectrum from the X-ray all the way to the infrared of Tau Ceti in this case, but exoplanet host stars in general with many other people. So currently making spectra for JWST targets, and now this is for Habitable Worlds Observatory target. And I'm also the science lead on the Mantis CubeSat, which will be launching in a few years. Thanks. Oh, sorry, I'm also the organized solar and stellar seminars for LASP, so if you want to give a talk down on his campus, please let me know.
Thanks. I guess I would have gone way over 1 minute if I crouched down there, so get air horned. I'm Daryl Seligman. I am a NSF postdoc fellow and the Simone LSS postdoc fellow as well. And I work on small bodies, things like the interstellar objects. On the left is that's not actually an image, that's an artist's depiction of Oumuamua, which was the first interstellar object, which was very mysterious in lots of ways. And we also just recently discovered this new population of objects, which kind of share some of Oumuamua's mysterious properties, these dark comets. And then specifically, I'm really excited about LSST and work on the LSST Solar System Science Collaboration, and specifically what LSST is going to find in the next several years about interstellar objects and dark comets. So if you're interested in getting involved in LSST or the Solar System Science Collaboration, come and talk to me. Thanks.
I'm next, which is why I was the runner. I'm Dave Brain. We'll do 3 things. First, science topics. In 6 words, do habitable worlds require magnetic fields? That's a topic that gets me out of bed scientifically in the morning. And I'm really interested in that. And I'm trained as an observer, someone who uses spacecraft data, mostly charged particle and magnetic fields, to study processes related to escape of atmospheres from solar system planets. In recent years, I've become interested in exoplanets as well. And that guiding question, do habitable worlds require magnetic fields, can't be answered unless we can answer a larger question: what properties of a star and what properties of a planet combine together to allow a planet to retain its atmosphere? So that's what guides me scientifically, but I work on spacecraft data in other areas as well I can tell you about later. Personally, I do the expected Colorado things. I trail run and cross-country ski and downhill ski, and I'm hoping to maybe organize something for the department in January in a snowy location. And my kids are I have a senior in high school, a sophomore in high school. So if you want to hear me brag about my kids, come talk to me. If you don't want to hear that, avoid me. Third one is I am just finished my 3rd month being chair of the department. I'm still climbing the learning curve. This department was already a community, and I'm hoping that the department continues to feel that way and that community feeling strengthens. And if there's a ball that you notice that is dropping or something that you would like to see change, come talk to me. I can only address things that I know about.
Hi, I'm Prashun Thang. I'm a GILA postdoc working with Mitch Begelman and Jason Dexter. So far, I have mostly worked on how matter flows around the black holes, and recently I'm working on how black hole pumps out the energy and it affects the closed environment in it. And if I can escape the black hole's influence, sometimes I work on the accretion flows around the young stars, which is called protoplanetary disk. Yeah, that's it.
Hello, my name is Dmitry Uzdensky. I'm a professor in the physics department at the Center for Integrated Plasma Studies. However, I do mostly astrophysical research in theoretical and computational plasma astrophysics. And what I do is I'm trying to understand how fundamental collective plasma processes like turbulence, magnetic reconnection take place in extreme environments in the presence of relativistic and radiation effects, environments of black holes and neutron stars. My research is mostly theoretical, using analytical methods and a lot of particle and cell simulations done mostly with Greg Werner, who will be talking about this later, and postdocs and students both in the physics department and in the APS department. And I collaborate with Mitch Begelman and Jason Dexter.
Thanks. Cool. So somebody changed the formatting. Sorry about that. But you can all read that, right? My name is Tyler McMacken. I am a grad student in my 6th and final year at CU, and I study quantum effects inside black holes. I work with Andrew Hamilton, and I'm looking at the most extreme region of the universe and how quantum mechanics combines with general relativity in meaningful ways. And one of the ways we probe that is with Hawking radiation, which might not look like that. I also play music, and that's it.
Okay. Alex isn't here. That's neat. Yeah, Alex. Yeah, very busy, too busy to be here. He has these cool things. Okay.
Hi, I'm Greg Werner, and I work in the Center for Integrated Plasma Studies, collaborating mostly with Dmitry and also Mitch Begelman and Jason Dexter. Mostly doing PIC simulations to understand especially how energy is converted between different forms mediated by plasma. And I would say at the moment, the single question that interests me most is how does kinetic scale plasma phenomena manifest at large astronomical scales? And how do we find that out with any sort of certainty? Thank you.
Hi, I'm Patrick O'Brien. I'm a postdoc over at LASP, working with Paul Hain and Margaret Landis, and also a honorarium instructor in the APS department this semester. I study the illumination and thermal environment inside permanently shadowed craters on the Moon and the dwarf planet Ceres. And I'm particularly interested in finding the very coldest places on these bodies where you might get not only water ice, but also exotic ices like CO2. So I use a combination of NASA spacecraft data and a host of numerical models to understand the history of volatiles in the inner solar system.
Hi, I'm Harish, and interestingly, this is my full name, only Harish. And I joined last month only as a research scientist. I'm working with Paul Hain and Margaret Landis, and my major research area is planetary remote sensing. Here, I'll be working to understand the geological processes on Mars, Moon, Ceres, and asteroidal bodies. Thank you.
Hello. Hi, everyone. I'm Zach Berta Thompson. I'm an assistant professor in the department. I gave a very, very long talk last week. But broadly, I'm excited about transiting exoplanets, observing their atmospheres. I like using telescopes in space and also on the ground. I have found myself like teaching classes over at SBO almost every semester for the past few years. So I guess that means I'm like excited to try to get students behind telescopes as well. So always eager to talk about ways of doing that. And as I've lived in Colorado for 6-ish, 7-ish years now, I really like it here. I like going for little walks. We just started sourdough season again, so like starting to bake again. Although it was like really hot yesterday, so it was sort of annoying, but whatever. And like Adina and my grandma, I like to knit and crochet. All right.
Hi, I'm Kirk. I guess, yeah, the formatting changed also. Yeah, there was some white text, but whatever. I modeled the broadline region of quasars. This is a cool graphic that Gillett people made for us about our recent paper. I work with Jason Dexter, and in my free time, I like to ski. Did 42 days last year. I like to hike, and I like to play sports. So if you ever want to play soccer with the department, hit me up.
Hi, everybody. I'm Sebastian Panetta. I'm a research scientist over at LASP. I am interested in all things magnetism for stars and substellar objects like brown dwarfs across multi-wavelength space, some X-rays, the radio, observationally, combining theory. And right now, I'm also particularly interested in the magnetic interactions between stars and planets. That's what the schematic is shown here. And yeah, so please come talk to me if you're interested in any of those things. Lots of interesting projects in terms of theory and observation. So thank you.
Oh, wow, it changed. I just put a black background on there. And my name is Ben Oppenheimer. This is not the live updated version. I'm a CASA researcher, and I'm interested in this triad. Yes, I'm a Zelda fan a little bit. I don't have time to play the new game, Tears of the Kingdom. But I work with the camel simulations, amongst other simulations, cosmological hydrodynamic simulations. And I'm following the gas from the large-scale cosmic web that you see on there on your left, all the way down to galaxies. And we have a new exciting cosmic origin spectrograph observing program that was approved this round. So I'll be working a lot on that. So astrophysics, cosmology, simulations, and now machine learning, come ask me, and also observations. Thanks.
Yeah, apparently someone really mucked up everyone else's slides, so good job, that person. Let me just, feel free to come down. Yeah, I'm just gonna see if I'm connected to the internet and if it wants to update these slides. Because that would be cool. Yeah, now it's updated. It just, oh, I'm sorry, Ben. Now your slide looks really nice. Oh. Yeah. Exactly. It's beautiful. It's a very beautiful slide. You did a really nice job. Maybe the projector will work, potentially. Maybe not. Yeah. Yeah, buddy. Uh-huh. Okay. Gina and, oh wait, you're on here twice? That doesn't make any sense. Okay, well, Justice, you're up soon.
Hi, I'm Katrina Murray. I'm originally from Scotland, but I moved here a year ago. And I'm interested in all things transiting exoplanets, observing them from the ground and also in space. I'm interested in detection, in atmospheric characterization, using things like GWST. And I have side interests in stellar stuff, so spots, flares, how that impacts our observations. And when I'm not working, I spend a lot of time hanging out with my friends' pets as well. So thank you.
Hi, I'm Justice, and I work with Erica Nelson. I'm a graduate student, 6th year. I work on a lot of stuff with galaxy morphology and the stellar populations within them. So this is just one of the things I'm working on. On the left is an image taken with Hubble, and as you can see in the center, there's not really anything to see. But when we look at the same thing with James Webb, what we see is this really big, long red galaxy pop out. We found a bunch of these things, and we're trying to figure out what they are, what their shapes are, what kind of stellar populations are inside them. Yeah, thank you.
Well, you bet I am. Hi, I'm Ben, and as Erica's doing, I'm a talker, so she's probably going to have to air horn me. I'm a faculty member in the APS department. I do math. I like math a lot in different ways, and I like teaching it in our graduate core in different places, and then also subjecting undergrads to it when I show up in our general astronomy classes. The 1030 students got to see derivatives today for fun. As part of our math, we've figured out open source tools for doing astrophysics and made them. One of the cool things we found out is sometimes if you make the math harder, it then gets easier, especially on a computer. And even just notationally. We use that math to do things involving dynamos and stars, especially fully convective M dwarfs. That's been a fun thing for the last little bit. We're kind of novel in the world for being able to actually simulate those. And I also like right now trying to understand rain on planets like the Earth. So I spend a lot of time trying to understand rain and condensation because it's really cool. Occasionally, I also raise chickens and sheep and bees, and some children too. So anyways, that's me. Air horn? Air horn? Please? I like the air horn. I feel like we're on Planet Money. So, all right.
Hello, my name is Leon. Before I coming to CU, I work on different stuffs. For example, I work on something called diameter mixed stars, and I predict their observational signatures, like from the gravitational wave or light curves, bolometric light curves. And I also work a little bit on astrostatistics, like using machine learning to look for interesting stuff in big catalog of astronomical data. When I come to CU, I switch my research focus, like I work on simulation of black hole accretion disk. And I also ray trace black hole images to predict how they look like if we use telescope to observe them. And I'm I'm still learning. I'm fairly familiar with GPU computing. One fun fact is I previously studied at a university also called CU, so I am transiting from one CU to another CU. So yeah, thank you.
Is it this one? Okay, perfect. So my name is Chloe Benton. I'm a second-year grad student here, and I work with Erica Nelson, similar to Justice. I do galaxy evolution and structure, but focusing specifically on cosmic noon epoch, and that's redshift 1 to 3. So we noticed that galaxy structure depends definitely on wavelength, and so that's just kind of my focus and topic.
Hi, I'm Jonathan. I'm a 6th-year grad student here, and I work at the National Solar Observatory. And so I combine infrared spectroscopy and MHD simulations to study the dynamics of carbon monoxide in the solar atmosphere, especially as a diagnostic of cool, kind of like 4,000, 5,000 Kelvin gas
throughout the solar atmosphere, especially at heights where the other diagnostics that we use aren't sensitive to gas at that temperature. And that involves a non-trivial amount of gas phase chemistry, which as a physicist, I am 100% qualified to talk about. The other half of my job is I'm an ALMA ambassador, which means that if you work with ALMA data, it is part of my job to help you with that. And if you want to make beautiful solar mosaics like this that are there on the right, then you can join my ALMA data analysis workshop later this month. It's coming up in a couple of weeks. You can register now. If you register soon, there will be free lunch. If you register late, no food for you.
Yeah, hi everybody. My name is Dmitry Vorobiev. I'm a research scientist at LASP, and according to Rate My Professor, not a very nice person. So I'm part of the group at LASP who are astrophysicists. We spend a lot of time trying to develop new science cases and new instruments, especially in the ultraviolet regime, from the extreme UV to the NUV. In particular, right about now, we're trying to put together a proposal for a long-duration balloon to do an NUV integral field mapping of galaxies in about 0.06 to the 0.1 to 0.2 range. So if you're into nearby galaxies and you want to map the heck out of them in the NUV spectroscopically, you should come talk to us. Thanks.
Hello. Right. Hi, I'm Brianna Endall. I'm also a research scientist at LASP, working in same group as Dimitri. So right now I spend most of my time working on a UV or far UV spectrograph CubeSat mission called Sprite. Sprite is gonna study supernova remnants. It's gonna map star formation regions and also study the ionizing escape fraction of galaxies really nearby. And then I am also going to start leading a new mission called Mantis, also a 12U CubeSat, also UV, except it's going to simultaneously cover the visible all the way through the extreme UV. But with the primary science mission of determining the influence of the UV stellar flux of host stars on exoplanet habitability. Oh, that word's so hard. So yeah, that's what I work on.
Really? All right. We're done, guys. Great. Thank you.
36 people, 36 minutes.
36 people, 36 minutes. I'm sorry. I just had to. Okay. Thank you, everybody, for coming. Thank you for all of those who participated. I feel like I know more people in this department now, which is very exciting. And please join us each and every week for coffee and snacks in the APS office. Thanks, guys. Have a great day. Thank you very much.
You really are in 26-dimensional space now. Holy cow. Sorry? String theory. Managing to publish this stuff. Or do you have drafts?
I got my brand new file published.
Okay, good.
So that's come out. Paper. It's
getting over your referee.
I haven't yet submitted it, but we'll see where it goes. You know it's going to get a little.
Yeah, I know. I think that's great.
Hi, I just wanted to ask a quick question about your theory about 11. Or 20, yeah. Or universe, sorry.
26 dimensions.
26 dimensions. So you said, and you said exo universe. What did you mean by? What did you mean by?
I don't mean exo universes. That's really the string theory does predict a plethora of laws of physics, which is why there's this notion that there might be a multiverse out there with many different laws of physics. I'm motivated to do this work because of what happens inside black holes. I've worked with my work for 10 years or so. And we meet super high physics. I mean, super high energy physics inside black holes. It's the only other place which gets to be as energetic as the Big Bang. And so what I'd really like to do is harness what I'm doing to do actual calculations of what happened at the very beginning.
Yeah, no, that is exactly what I would like to go into. Like what?
Okay. Goes in there and